Hello guys and welcome. In today's video, I'd like us to focus on previous exam paper questions. So let's first look at the one that I displayed on the screen right now. So we're gonna go through steps of how we answer these two questions. Okay. So the instructions are clear. Attempt all question and in your solution show all necessary steps. Question 1a says that we should solve the initial value problem where they gave us this differential equation with the initial conditions. Okay. So this initial condition, we're going to use them at the end to help us find C. Okay. So in a way now, let's start. They gave us that we have square root of 4 minus x squared dy by dx equals y, ln y. Okay, so how do we solve such a problem? Since we see that the function of x is along that side and also the function of y is along this side, we can use the technique of separable of variables. Okay, let's separate the variables. In a way, we can separate the variables and end up having 1 all over ln y dy equals 1 all over square root of 4 minus x squared dx. Okay, I'm pretty sure everyone is comfortable with separating variables. Otherwise, now what can we do? Notice that on the left side, we can start integrating, and also on the right side, the same thing. So here, notice that ln y and its derivative are in this function. The derivative of ln y is 1 over y. That means we can simply solve this one by u substitution. So let u be ln y. So if u is ln y, it means that du is just 1 all over y dy. Okay, 1 all over y dy, it's our du. Okay, so notice that 1 all over y, 1 all over y dy, it's already there, and of which is our du. So this makes our life so much easy. Okay, so what about on the right hand side then? On the right hand side, if you notice, you will see that this integral is basically easy to solve when we are using the trig substitution. So what is going to be the substitution? This one, it's sine substitution. We're going to use sine. Okay, so here we're going to say x equals 2 sine theta. Okay, so for those of you who maybe might have forgotten why do I specifically have 2 there? Remember that the substitution is basically x equals to a sine theta. Okay, where a is a constant, and here the constant that we have is 4, but then this one here is basically not a, but it's rather a square. So if a square is 4, it implies that a will just be 2. Okay, so that's why here I have my substitution as x equals 2 sine theta. My a is 2, so I just plug that 2 right there. Okay, um now once we have something like this, we can start differentiating. Say dx, now it's just going to be 2 cos theta d theta, right? Then let's go and plug that into our integrals. We're going to have what? For the left hand side, we're basically going to integrate 1 all over u du, right? And this will be equal to integral of 2 cos theta d theta. I'll put it on the side right there, then divided by square root of 4 minus. Now I know that my x here is 2 sine theta, so if I square it, I'm just going to have 4 sine square theta. Okay, so notice that on the right side here we have what is common, which is 4. So we're going to take that as a factor out. And on the left hand side right here, the integral of 1 all over u, this becomes ln absolute value of u. Okay, then equals to, then here I'm going to have integral of 2 cos theta, then divided by, if I take the 4 as common and it's under the square root, it's basically going to become 2. The square root of 4 is 2, right? Then what am I going to remain with under the square root? Since we factor out 4 here, we're going to remain with 1, then minus sine square theta, like that. Then now on the left hand side, let's bring back what was our u. Our u, we know that it's ln y. So we basically have ln of ln y equals integral of this 2 and that 1 will cancel. So we basically have cos theta all over. Under the square root here, we have 1 minus sine square theta, which is the identity that is equal to cos square theta. So cos square theta under the square root will just become cos theta. Then they will cancel out as well the theta. So basically we have ln of ln y equals, I don't know, integral of 1 d theta, right? So now, if we are having something like that, we'll end up saying ln of ln y should be equal to theta, then plus c. Okay. Now, our initial problem that was given, it was in terms of x, not theta, right? So let's bring back what is theta in terms of x. Remember the substitution that we made? We said that x is 2 sine theta. I think we can find the relationship between x and theta from this one. So if we try and make theta subject of the formula, I notice that from there we'll say that theta is basically going to be arc sine of x over 2, right? Divide both sides by 2, you will have x over 2, then take sine to the other side. Then theta is basically arc sine of x over 2. So now let's plug that in here. We'll have ln of ln y equals arc sine of x over 2, then plus c. Okay, since it's an initial value problem where we know that the initial condition was given as when x is 1, y is e. Let's go plug that in there. Our x is 1 and y is e. So if we plug e here, we'll have ln of ln e. Ln of ln e equals to arc sine of 1 over 2, then plus c. What is ln of e? Ln of e is 1. Then we basically have ln of 1 equals, what is arc sine of 1 over 2? That is pi over 6, then plus c. Now basically, c is going to be equal to ln of 1 is 0. So we're going to just transpose this to the other side, then it just becomes negative of that, which is minus pi over 6. So then therefore, we have, we come back here, we substitute our c, we'll have ln of ln y equals arc sine x over 2 minus pi over 6. Okay, so this is the answer for the first problem, just like that. Or if you like, maybe you might try to simplify and say ln y equals to e arc sine of x over 2 minus pi over 6. Okay, if they didn't specify to you that you should solve for y explicitly, that means to have y on its own as subject of the equation, you do not have to bother. You can leave it here. You will get full marks. Okay, so now let's go to B. What was B saying again? On B, they say that we should sketch the region in xy plane where this solution is unique. Explain, and that is 3 marks. Okay, so now they are talking about unique solution. So what basically we need to remember here when we are dealing with a unique solution is just two important things. You have your f of xy. Your f of xy basically is dx over dy. So you're going to look for where dx over dy, you look for where it is continuous. Where is it continuous? And also the partial derivative of your function f of xy, partial derivative of f in respect to y. You're going to derive that function f of xy, then also investigate where it is continuous. Okay, so basically we need to do these two things, then sketch that region. So we're basically going to find the domain, right? So what is going to be our f of xy? Remember we were given the square root of 4 minus x squared dx by dy equals y ln y, like that. Okay, so like I said, your f of xy is basically when you have dx by dy as the subject from this differential equation. So if we put that as our subject of the formula, we see that dy by dx is just y ln y, then divided by square root of 4 minus x squared. So now we have to find the domain of this function, because this function is basically our f of xy. It's a function of x and y, right? So let me write it here neatly. We know that our f of xy is y ln y over square root of 4 minus x squared, just like that. Okay, so can we investigate the domain of this function? If we look at the denominator, you will see that y is an element of all real numbers. But then for this one, we see that since it's a ln function, we know that y cannot be equal to 0. So y must strictly be greater than 0. This is where this function is going to be defined, right? So that's all in the denominator. So now let's go to the numerator. Under the square root, since we are dividing now, we have to be strict that 4 minus x squared must strictly be greater than 0 as well. Because now if 0 is included into the thing, you cannot divide by it, then it's not defined right there. So now this is not part of the domain. The 0 is not part of the domain. Okay, so now um, 4 minus x squared is a parabola facing downwards like that with a z face. Where does it intercept the x-axis? It intercepts at minus 2 and 2. So if we say that this function that I just drew here must be greater 0, in a way it's positive. Where is it positive? Above the x-axis, that's where it's positive, okay? So in a way, I'll just say this is the region where it's positive, and going down like that, from here, going this way, it's negative, and also going that way, it's negative, like that, okay? But then now we are just interested the way it's positive. So we see that it is positive where x is between minus 2 and 2. Okay, so that is how you find the things. Don't try and solve this and transpose x that side and take the square root, and now you end up having something I don't understand. So don't make that mistake. Just investigate your parabola like that, then you will find that it exists where x is between minus 2 and 2. Okay, so this is where f of xy is continuous. So therefore f of xy is continuous. It's continuous at y greater 0 and x between minus 2 and 2, like that. So now the other thing that we have to investigate is the partial derivative of f in respect to y. So if we take the partial derivative of f in respect to y, where is f? F is this one. So if we take the derivative in respect to y, we are only interested in y. So leave out this function 1 all over root of 4 minus x squared. We're going to treat that one as a constant, right? So we're going to leave it out like that. Then we're basically interested in the derivation of y ln y. So y ln y, to derive this, we use product rule. So first, let's derive y. If we derive y and leave ln y, the derivative of y is 1. So we end up going to have ln y alone like that right there, okay? So now, say plus, by product rule, now we leave y and we derive ln y. The derivative of ln y is 1 over y. Okay, so y and y will end up cancelling like that. So basically, the partial derivative of f in respect to y is equal to ln y plus 1 divided by square root of 4 minus x squared. So this is your partial derivative of f in respect to y. So now also similarly, you have to investigate where is this function continuous, okay? So if we check again in the denominator, we see that y has to be greater than 0. That is the domain of the denominator. And now also at the numerator, we're going to still have the same domain because it's still the same function, isn't it? So we just have minus 2x is between minus 2 and 2. We still have the same parabola. Okay, so now we have this as our domain. And also for our f of xy, we had the same thing again. Okay, so now for the part where they say we should sketch the region, we are going to use this to sketch the region. Okay, so in most cases, the domains are the same for f of x and for f of xy and its derivative in respect to y. So now if we sketch that domain, we're going to have something like this. This is my y-axis. And maybe let me put my x-axis right there. But then be careful that your x-axis has to be dotted line in this case. It cannot be solid, okay? It cannot be solid because of what? Because of now we want y to strictly be greater than 0. Remember that on the x-axis y is equal to 0, but 0 is not included here. There is no y equal greater or equal to 0. It's just strictly y greater than 0. Okay, so we do not have to include where y is 0, which is at the x-axis. So that's why I have my x-axis as dotted lines like that. So I have my x-axis like that. So now we have accounted for this one. Now let's account that means for y greater than 0, all the values that are greater than 0, for all the y values that are greater than 0, they are this side. Okay, going up like that. So now let's account for the second one between minus 2 and 2. So let's say my negative 2 is right there and 2 is here. So I'm gonna draw dotted lines vertically like that on minus 2 and 2. Then the last thing that is remaining now is just to shade the region. Okay, so we know that y must be greater 0, and we agree that these are all the values up here and between minus 2 and 2. So this is the region where we have a unique solution, just like that. Okay, yes, so thank you very much for watching. We have come to the end of the video. Stay tuned, we're gonna do more past paper examples, and yeah,